Hello, everybody. Thank you very much for being here at the fag end of the Hadoop Summit. I'm sure you have enjoyed, and right now we are probably looking forward to going and having a nice glass of beer. So hopefully, and luckily, this is a topic about entertainment, so hopefully we will be able to keep you entertained for the next few minutes. So let's get started. This is about personalizing live TV. So one of the things then when we see the difference between our experience on the web and the experience on TV is while on the web we currently have a lot of personalization, and we are actually recommended various different programs and various different contents by websites like Netflix. But what happens when we go to the TV is really that's what we essentially see. Not a very nice thing to see when especially you have just come back from work, really tired, and you are presented with that view of about more than 1,000 different programs running on different channels with very minute fonts, and that to partial statements. So what we really end up being as that sort of a viewer, not really very happy. So this is an idea that we sort of came up with when we were thinking of the amount of data that the setup actually provides us with. What sort of an experience can we potentially get? And so this is one of the techniques that we will show you on how we can actually totally change the experience of how we watch TV. So the concept actually, the first thing that I would like to introduce is that one. So the EPG on your mobile phone. Nothing new. You already have loads of apps out there that actually does it. But this is an integrated app that actually allows you to select the programs that you want, not just see them, but you can actually select them and book them for when you want to watch. So for example, you are commuting on the train, and you can just browse through your phone, look at the EPG, select the programs that you would want to watch once you go home. And what it does is it sends the information to a backend cloud infrastructure, which as we will actually show you through this presentation, will be a Hadoop or similar sort of installation. And then that information is fed back into your entertainment system at home, and it's booked for you for when you actually reach home and switch on the TV. You don't have to go through that list of programs again, and you are actually presented with what you already have selected. Now, we do believe that this is the sort of viewing experience that we want to end up with, not a grumpy face. Now, let's see what actually is happening behind the scenes. So, that blue line, the blue line over there, that's what I just showed you. But what can potentially happen is that once you have selected your choice, that choice can actually go into the system, and that can be actually recorded over a period of time of what you like and what you are not selecting. That's actually a very useful information as well, what you don't select. And all of that can be mashed up with the information that we get directly from the satellite about the EPG for the forthcoming information. And as well as the other source of information, that red line, that is based on when you're watching the TV, when you are just flicking channels and going from different channels of what's exactly what you're doing. That information can all be fed in, into that profile analyzer for the entire population of people who are watching TV. So that will be quite a big chunk of data that we can do, process. But the best part is the bigger the data, the better for statistical analysis. And that can enable our recommender engine to actually create recommendation for you going forward. So going forward so you don't have to actually do that every time, or probably never. In fact, if a sufficient large population actually uses such a system, then based on some very basic information, you can actually already start seeing your personalized content on the TV right from day one. That gradually gets more refined as you interact with your entertainment system. And that's all done by this here in the recommender engine. And so moving on. So what sort of data we can actually get? So there are basically three primary sources of data. The mobile app, because the user will actually select what he likes and what he doesn't like. The set-top box, there's first-hand data about the person's viewing behavior. I call that flick stream information because you will probably be flicking the remote, and similar to click stream that we get on the web, you can have the flick stream information coming from the set-top box. And then you have the account information that you are actually providing along with when you actually subscribe to this service. So the account information is actually interesting because this can give us some personalized information, like, again, very much voluntary. Like we know that for any account creation, you have some voluntary questions. But if you do agree to answer those questions, then things like, say, gender and some basic interests, like are you interested in business content or maybe movies or that sort of information can be captured at this level. So these are the primary data sources. Now, but we also have a lot of secondary data sources. I mean, I've picked up social media because this is a very good example. Essentially, what can happen is your viewing pattern. I mean, a person's viewing pattern is impacted a lot by what their friends and their circle of acquaintances actually view. So normally, the normal thing that happens is you view a program or a game, and then you discuss that with your friends or other people, or maybe you actually get into some sort of forum where a lot of people are discussing about that. So based on your interaction with the social circle, a lot of the information can actually be fine-tuned to that person. And we can actually find similar people using that. So this is one of the premises from where we can actually create a profile for a user even before we know anything at all for that user, so that if we get a little bit of information, we can actually match that user to certain profiles, and hence give a personalized experience right from the very beginning. So user profiling, so what we really need for this, from the first ability that we need to do from this, because we know that usually TV is not something that we watch alone. We usually watch it, there's usually one or two televisions in a home of, say, 4 or 5 people. And a lot of times there are multiple people viewing the television. So one of the challenges is the user profile. One of the challenges that we don't have in the web is because normally a single person uses a computer. But when it comes to a TV, there are multiple people. So the first thing that we need is granular user profiling at a single user level, so that we know for a single user what sort of behavior do they exhibit. And this information, as we will just see, can be used to actually disaggregate when we have multiple people watching the TV. We can actually disaggregate that behavior and derive the information about who are the various different people watching the television. So the user profiling for a single user we can get from that mobile app, because again the mobile app will be for a particular person. We can sort of safely assume that a mobile phone is used by a single person, so that will actually record the likings of a single person. And also set-top box information for single person household. So again, this might be an information that we can ask the user to provide voluntarily on account sign up. And so this information can be fed into the viewership disaggregation. So this is where you have multi-person households, where a number of people are actually viewing, and by using the individual profiles, we can actually we can segment these users into the various different program buckets. Various different segments, and we can. So basically, there are different types of segments. So we can have demographic, economic, say geographic. So these are the different types of information we can get, because set-top box usually from the mobile you can get geo information, or you can get geo information from the account information, and then again behavioral. So that's where the flick stream, as I call it, or the behavior of a user changing channels and flicking over from one channel to another channel. That's basically part of the user's behavior, how he's interacting with the entertainment system. So that sort of system, and then the last part, statistical information, are basically features which are automatically derived by the statistical techniques, which don't have a very clear logical definition, but which nevertheless are actually very useful in this sort of a system. So those are the various sort of segments, disaggregation segments that we can do. And we will, I mean, this is actually important that we will end up in creating the microsegments. Now, microsegments, this is, at the moment we know that there are some sort of targeting which goes on the television side, and some of the bigger companies have started targeting, but that targeting is based on content. So you will have like sort of some particular advert that comes in which is related to that content, but not on the user side. So this is an area where we can actually really get close to the user and specifically target either advertisements. So it can be promotional material. Say the government wants to promote some particular message. Say the government wants to promote message about diabetes and wants to specifically target people from the African and Asian origin because they're more likely to have diabetes. So these sort of information can actually be specifically targeted using this technique, because we can create really small, well-defined segments within the population. And again, because we are operating on the 3 different channels, so again, we can have this sort of segmentation on the TV, mobile, and web. And again, a person's behavior will be different on the different channels. So there is a lot of scope, not just, I mean, this can definitely be used for targeting content, but there's a lot of scope of going beyond that, like putting advertisements or specific information on there. So at this point, I'll hand it over to Thomas.
Thank you. So from in the second part of the talk, I will explain some of the details of the recommender system algorithm, but just keeping it high level, just to understand, how you would frame the recommender system problem, and how you represent the users, and how you sort of build the whole system. Just out of curiosity, who does machine learning here or recommender systems in the room? Okay, just 1 or 2. Who is in media? No one. Okay. So, the challenge here is basically to represent sort of the user profiles in a way that recommender systems would understand, and the way, I mean, it can be represented again on the user and on the household level, and it can be basically understood in certain ways. So you can think about how you represent the user, what you know about the user, and based on the data, based on sort of the observations, you can collect certain features. Basically, you can describe users based on certain features. And the simplest case is basically when people watch TV, which could be like when people watch TV during the day, when people watch TV during the week, or even you can sort of understand sort of seasonal variations. And that could sort of describe a user in a way that, this is a time, this is at 8 o'clock at night. Some certain users would go and switch on the TV. The sort of more advanced one is understanding users based on their features. So, for example, understanding users what they like, what sort of content they like. For example, what's their favorite director, what's their favorite actor or actress, what sort of how you can describe them based on the demographics, what's their age, what's their income, for example. Also, so you can represent users based on that. And then the next level is basically when you go with more on the machine learning part, when you try to learn some features, when you try to describe, I call them latent because the way they represented are sort of just the numbers, just a bunch of numbers which would represent your users. And that can be learned from what the user watched historically. So that you can say that this particular user it has certain features which would relate to certain items. So you can see how similar they are. And these are the things you can basically put into a recommend system. Some of the algorithms would work like this. And then, obviously, if you combine it all together and represent the user based on all the features, you get the most powerful version of it. And if you collect data from multiple channels, then you get all the things you need. Well, in the first round. So, as Ranadip mentioned before, we want to basically understand users in the household. So you would like to sort of put them into buckets and understand them, based on their behavior. First, based on how they differ from other people in the household, or also based on sort of what sort of data you can collect. So, and this is a sort of iterative way. So if you know who is watching, you can understand their features. You can basically describe the people. But if you only know that it's a household level, then you need to sort of do it iteratively. So, like, first of all, you have to separate the people into separate buckets. So, like, you have users here and users here, based on, for example, in the simple case, based on time. So people tend to watch TV at certain times in the day, and then if you add more complexity to it, you can say based on time and based on genre, based on sort of the type of the content they watch. So you can have a more understanding of the user. So in a way, you sort of learn the features of the user, but you also learn who is watching at the same time. And then let's say it's a learning process, and then once you basically completed the learning process, you'll end up with certain features which would describe certain users. In this example, we have like 4 users in the household. And again, it can be basically a mixture of all the features I described in the previous slide. So it can be just based on what they like, for example, what sort of genre they like. It can be based on the combination of all the 3, when they watch, what they like, and what's the history. And it can be, just any of those 3 basically. And then the next question is basically how to, when you learned your features of your household, how to present it back to them. And one simple scenario is basically when you create a user interface and say, this particular household has 4 users. And this is what we learned about them. And when the user switches on the TV, you can say, you select your profile, which would be the most, which is basically you. And the challenge here is basically is to get this, get this description out of the history. So, for example, the time feature you can describe this way, like you would watch during the day. You can describe the genre, like just the genre, or you can describe type of shows they watch. For example, property shows during the day. That's usually what's on TV. You can even go to more details on the sports level. You can say it's a Manchester United fan. Yeah, so it has a number of options in this case, but this is a sort of manual selection, and users has to say, "Oh, this is me," basically. And then, on a sort of more advanced way, you can select users based on their behavior. So that is basically. At the top, you get the timeline of the household. So, like people watching certain things during certain times, and then there is a profile matching engine in our sort of our stack, which would start collecting data from the household in sort of real-time way, and try to match whatever the event collector saw in that short period of time, try to match it to certain profiles. For example, if people start watching like children programs in the morning, it will match to someone who has a very similar profile in that household. Or if they start watching like sport events and then we know that there's a sport fan in the household, it would match that profile. And the reason for that is because when the system knows who is watching, that's the point when you can start making personalized recommendation, and that's the point when you can, basically, sort of represent all these recommendations, particularly targeted to those users. But if let's say there's no match let's say the user is watching something which doesn't match any of the profiles, you can still have a recommendation on the household level. You don't have to go down to the user level. So it's a sort of hierarchical structure. So yeah, this is basically on the profile matching part, and I just want to jump into the recommendation part when you have, when your profile is already selected, so the system knows who is watching the TV or who is watching any device, and you want to recommend basically. That's a scenario which is probably most of you are familiar with, and in this case is a sort of classical recommendation problem when you collected certain events from the past viewing history. For example, this particular user has a couple of cartoons in their profile, some science fictions, and then that has a combination of like some drama and some sport events. And then, based on a sort of a standard recommender system, which could be like for example, one of the most widely used is a matrix factorization recommend system, would give you a list of content to recommend. And this scenario is basically just a classical problem. So you get a list of problems, and then you get a feedback collector, which would feed it back to the original system. So you get more feedback on. But here, I mean, obviously there are problems here. For example, some users don't have any history, and some users have sort of multiple different things they watch. So in the case of no history, you can basically have certain strategies. You can basically understand about the user before the user comes to the system, or understand about the user based on their, let's say they have to fill in a survey, and then you can understand what they would like to watch. So it's a sort of initial understanding of the user, and then you can make recommendations. These are sort of known problems in the recommender system domain. And this is a point when you can start producing advertisement as well, targeted advertisement, because you know about the user history, and you know about what sort of content they would watch. So you can basically use the same strategy to recommend advertisement for those users. And but the more interesting part in this one is based on how to create a channel which would be purely personalized, and which would still look like a live TV broadcast, or it should look like a live TV channel. The reason for doing this is because most of the people are kind of lazy, so they just want to go home, tune into the TV, and tune into a channel, and then they just want to watch. They don't want to find stuff. They don't want to go to the user interface. And still around 80% of the people go back and watch live channels. They still prefer live broadcast versus like streaming content. So, but you can frame the whole problem as a sort of way that still looks live, it's still broadcasted, and it's still a TV channel, but could be personalized. So, in this case, for example, obviously we already learned about our users, and we understand their profiles. We know their viewing history, and we can sort of represent their features. We understand the user. And we have a number of content. So we have a content catalog, which could be like video on demand. It could be catch-up TV. It could be even live TV. So you can, you know what is available at any given time. So based on that, I mean, if you create a scheduler which would pick the best program for this particular user or this particular group of user, and broadcast it or stream it into your device, then you can create a live broadcast which would look like a normal TV, but could be personalized. And the scheduler, I mean, in this case, the scheduler is the most tricky part. It basically has to optimize between a number of things. It has to understand what the user would like, or what the group of users would like. It has to sort of take care of the copyrights, take care of the availability of the programs, and also have to take care of how to put them together. So it will satisfy the household, it will satisfy the user, it will satisfy whoever is watching. But if you see this sort of problem as a sort of, as a so you can understand it in different different granularity. So if you want to go with the easier solution, when you have as a broadcaster or as a TV provider, you have one single feed, one single channel you can broadcast to, then you can create a single channel approach which would satisfy most of your population, which would be like sort of a personalized channel for the whole population. You can understand that way, and it will be broadcasted into a single slot. On the other hand, I mean, that's the easiest way in terms of infrastructure and in terms of delivering content. On the other hand, you can go down to a device, or you can go down to a user or the household. When you have, you can personalize a channel for a particular household or for a particular device, or even for the combination of any of those. And that is a bit tricky in terms of the infrastructure, in terms of delivering the content. But the best, I mean, in terms of feasibility, the best part is in the middle, when you have certain channels or certain content for a group of customers, which you can understand as a sort of segment of the population. And that could be like location-based, that's the easiest, so you can broadcast to certain areas, different content. Or you can even go down to the street level, postcode level, as much as you can understand about those customers. Or it could be based on demographics like age, the gender of the population. And these segments can be, you can create a sort of personalized content for these segments. And obviously here, again, the advertisement angle of it is, for these segments, you have the content, but you have the advertisement, which goes hand in hand. And I have a couple of challenges here, basically. In the TV domain, one of the biggest challenges is new content. So you have a lot of new content coming in, and a lot of new content which you don't know much about. So, for example, we had this show called True Detective, which was broadcasted a couple of weeks ago. There's no viewing history on that. There's no any understanding who would watch it, apart from the marketing channels and the way they create the program. But in the recommender system domain, the best signal is always viewing history. So if that's missing, then you need to get some strategies in to match, to understand who would watch that, so you can recommend. And one of the strategies is basically understanding the similarity between existing content. For example, here we have Breaking Bad, which is a show which has been around for like 8 years. And a lot of viewing history, and we understand who is normally watching these shows, and understand the relationship between between existing shows, existing TV programs, and new content. And that it can be done in certain ways. It can be done based on content similarity, based on sort of the initial understanding of the market. And I just put them together. For example, here is because you have Breaking Bad, which is a bit of a gritty show, and they talk a lot. And you have this, again, another sort of gritty show. It doesn't exactly correlate, but every content is unique. But we can do this matching based on the genre, based on certain features of programs. And you can do the same with similar TV dramas. But one of the challenges is basically sports, which is a big part of the TV audience. When you have every event is a single event, it never happened before. It might have happened a year ago, but the situation was different. The teams are different. So in that case, it's a bit tricky to understand because it's always new content and it's always new teams. And so in this case, it has basically for every single sort of segment of the programs, you need to have a different strategy to match them together. In the case of football, it would be like the teams. It would be like what sort of type of sport it is. When it's showing what sort of whether it's sort of a cup or whether it's a championship league. So so just to illustrate, then for every single different content, you have different strategies to do matching. And the last thing I was going to mention is on obviously, the initial scenarios were simplified, so we would just say one single person is watching TV. But normally you get a group of people watching, and you get, basically you can have the whole family in front of the TV, you can have just one person. And the challenge here is to understand who is watching. When you have more than one person watching, you have to match the profile with these multiple groups. And also have to create a recommendation for a certain group of people, which is a challenge by itself. And here's just an example, like this is a normal profile of a household. Like you get the kids watching in the morning, and then you got maybe in mid-afternoon on a Saturday, most of the families watching, and then the parents in the evening. And they both have different profiles, and they both have different tastes. So the challenge here is to understand and recommend them something relevant. So the last slide is on basically trying to juggle and trying to have different problems. So the reason why we think this is a big data problem and Hadoop and the ecosystem is the best for it is because it has a lot of challenges on the data source, and it has a lot of challenges on the sparsity of the data and some of the unstructured nature of the data. So Hadoop is probably the best platform to pull this together and combine it and process it. And obviously we have a lot of problems on the devices coming from multiple devices, multiple teams, and then we have multiple people watching, so it has a lot of problem just by the data aggregation itself. The other thing is, as you know, that the streaming is going strong, so you have Netflix and other TVs, other sort of propositions, but then I think live TV is still, still a sort of thing which people want to go back to, especially population which are on the old side, because that's what they get used to, and this is what they usually watch. So not many people in the that segment would go to Netflix and watch streaming, which is kind of a very different experience. But if you do live, if you personalize live, and understand how to frame it in the same way, then we have the strength to make it more personalized. Customers would be happier, and also we can do more targeting on the advertisement side. I just hand it back to Randy for the last slide.
Thanks, Thomas. So our idea is that to have things slightly different than it has been on the web over the past, say, 10, 15 years on the web. What we have seen really is what it started with was a lot of content which was not really targeted, and then came the intrusive advertisements, which had been there for quite a long time, and people got really irritated by all the flashing advertisements and pop-ups and stuff. So instead, what we are sort of proposing is let's have very well targeted content and then have relevant ads on them, and hence not do the same sort of mistakes that we did on the web for live TV. Thank you. Any questions? Please feel free to come over to this microphone because there's a recording going on, so just for the sound. Okay. Yeah.
What tools do you use for the recommendation?
Yeah.
So, we use whatever the algorithm would require. So some of them are implemented by ourselves. So, for example, we use Scalding or Scala for recommendation, but also some of the matrix factorization methods are already mock-out. So we just take the code and change it. Because the TV is a slightly different domain, so you need slightly different recommendation systems.
And do you need any opt-in from the users?
Any?
Any opt-in?
Yes, we need.
Okay, thank you.
Okay, I think, yeah, thank you very much for sitting through, and wish you a very enjoyable rest of the evening and your stay in Amsterdam. Thank you.